Ladies and gentlemen, please permit me to introduce to you today one of the branch of mathematics today called calculus. What type of calculus is this? This type of calculus is called integral calculus. Why integral calculus? Because it deals with accumulation. However, ladies and gentlemen, I was told that calculus was introduced or developed by Sir Isaac Newton and Godfrey Leibniz. Both Sir Isaac Newton and Godfrey Leibniz introduced calculus independently by using different approaches. Sir Isaac Newton developed or introduced calculus between 1665 to 1666. He used a method to solve one of calculus called fluctuations. It was what he used today to describe what is called today called calculus. While Godfrey Leibniz introduced or developed calculus in the year 1675, and he used an idea or method called infinitesimal to solve one of calculus today. What does the word infinitesimal mean? A very small quantity getting close to zero, but it is not automatically equal to zero. However, ladies and gentlemen, calculus was later formalized by one of the greatest mathematicians today called Augustin Louis Cauchy, specifically in the year 1821. He also made a contribution to limit. However, ladies and gentlemen, we'll be looking at this mathematical problem to solve on an integral calculus today with combinations of trigonometry integral. The trigonometry integrals are integrals involving trigonometric functions such as sin x, cos x, and tangent x. I was told that integral calculus is subdivided into two major parts, and they are the definite integral calculus and indefinite integral calculus. What is definite integral calculus? A definite integral calculus is a calculus that consists of both upper and lower limit, while indefinite integral calculus does not have both upper and lower limit. However, ladies and gentlemen, this type of integral calculus is called a definite integral calculus. Why? Because it consists of both upper and lower limit. So, ladies and gentlemen, we'll be solving this problem, and the problem reads: the integral of pi over 2 and pi over 4, the square root of 1 plus cos 2x dx. The x is differential, but it is indicating that x is a variable of integration, and it is also part of integral notations. However, ladies and gentlemen, we'll be dealing with the upper and the lower limit first to solve our problem. So this is the upper limit, while pi over 4 is the lower limit. We will be teaching the upper limit, which is pi over 2 to degree measures. At the same time, we'll be teaching the lower limit, pi over 4 to degree measures. So we see a solution. On our solution today, we have the integral of pi over 2. The integral of pi over 2 to be changed to degree measures, we say times 180 degrees all over pi. Remember, pi and pi automatically cancel. We left with 180 degrees all divided by 2. If I divide 180 degrees by 2, automatically I will have 90 degrees. And this will be used as the upper limit. The same thing applies here to the lower limit. Pi over 4, we see times 180 degrees, all divided by pi. What happens? Pi and pi automatically cancel. We left with 180 degrees, all divided by 4. If we divide 180 degrees by 4, automatically we have 45 degrees. And this will be used as the lower limit. So in order to solve our problem, we say the integral of 90 degrees now and 45 degrees is square root of 1 plus cos 2x dx. How do we solve this? We'll be dealing with this trigonometry values within here by using trigonometric identities to solve our problem. And for this guy, which is one, we'll be using the Pythagorean identity. And the Pythagorean identity is sin square x plus cos square x will just be equal to 1. Remember, this one indicating this is the identity that we'll be using, called the Pythagorean identity. You want to teach a G or This Pythagorean identity was introduced by one of the greatest mathematicians today called Pythagoras. He made a contribution to the Pythagorean theory, which is c squared will be equal to a squared plus b squared. On this note, we'll be using cos 2x to solve. Oh no, the cosine double angle formula to solve our problems. And we'll also be using the cosine angle addition formula. So we have cos 2x. So we'll be using the cosine double angle formula to solve this problem. Or we'll also be using the cosine angle addition formula to solve this problem. So cos 2x now will just be equal to cos, parenthesis will be x plus x, the closest. This now will be equal to, I have cos x be multiplied by cos x minus sin x times sin x. What I have here, cos x times cos x will give us cos square x minus sin x times sin x will also give us sin square x, ladies and gentlemen. So we'll be using this to represent cos 2x in order to solve our problem. So however, ladies and gentlemen, so we see the integral of 90 degrees and 45 degrees. The square root of 1. We'll be using 1 to represent sin square x plus cos square x. So when I see 1, I'll represent this identity. So I will have sin square x plus cos square x. What I have here is plus. What I have here cos 2x. I'll be using this as cos square x minus sin square x in order to replace this guy. So cos 2x now will represent, you see, cos square x minus sin square x to solve our problem. What happened? Remember that this sin square x will be subtracting this sin square x. This sin square x will minus automatically this sin square x. So this and this automatically will cancel. So we see the integral of 90 degrees, and we also have a 45 degree. After we cancel this and this, because sin square x minus sin square x, this and this cancel, automatically we have cos square x plus cos square x. So cos square x plus cos square x automatically will give us 2 cos square x dx. Ladies and gentlemen, we will be using this automatically to solve our problem. Remember, this is definite integral calculus. Why? Because it consists of both the upper and the lower limit. So this can still be expressed as the integral of 90 degrees and 45 degrees. The square root of 2 parentheses open cos x equals always to the exponent 2 dx. On this note, ladies and gentlemen, we split them into 2. See, the integral of 90 degrees and 45 degrees is square root of 2 times parentheses open cos x all raised to the power 2 dx. Why we did this? We did it because we want to factor the guy out and we want to remove this square from the cos x. What do? We say in factoring the guy out, ladies and gentlemen, you see the square root of 2, the integral of 90 degrees and 45 degrees. What we have to remove the square from this, we multiply the guy by 1 over 2. We already have our dx here. So remember, this guy and this guy cancel, will be left with cos x here. Used to the exponent 1 is the same as cos x dx. So we have cos x dx. Remember that the integration of cos x dx is just equal to sin x. So in our mind, we have the square root of 2. Bracket open. The integration of cos x dx is just sin x. Bracket closes. Remember, we have our upper limit to be 90 degrees and our lower limit to be 45 degrees. Here I'm much, ladies and gentlemen, to solve our problem. We see the square root of 2. Bracket open. Sin x, now x represents 90 degrees, while x represents 45 degrees. So where I see x, I'll place 90 degrees. And where I also see x, I'll place 45 degrees. And remember, the upper limit, which is 90 degrees, will be subtracting the lower limit, which is 45 degrees. So since I have sin x now, it will be represented as sin 90 degrees minus sin 45 degrees. Bracket closes. Remember, ladies and gentlemen, we say the square root of 2, what we have here, sin 90 degrees is 1 minus sin 45 degrees is automatically 1 over the square root of 2. Bracket closes. What we do next? We see the square root of 2, bracket open, we balance the gap by 1. This will count to this one, this will count to this, we cross multiply. So 1 times the square root of the root of 2. So 1 times the square root of 2 becomes the square root of 2 minus 1 times 1 automatically is 1 over 1 times the square root of 2 is the square root of 2. We did it because we want this guy, and automatically the guy will be cancelled because the square root of 2 and the square root of 2 are the same. So automatically we left with the square root of 2 minus 1. Ladies and gentlemen, this is our answer for today on our definite integral calculus. Ladies and gentlemen, thanks for joining me on this math journey. Keep practicing, keep pushing limits, stay curious, and learn across to derivatives. Always remember that mathematics is the key. Don't forget to like, share, stay tuned, subscribe, and comment in the comment section. Once again, Lee Bomaset Jr., popularly or commonly known as Chachi, the all-time record breaker. Thank you.